Mitochondria and gut microbiome, unlocking the key to chronic disease prevention. Introduction. Mitochondria, often referred to as the powerhouse of the cell, play a far greater role in human health than simply producing energy. Emerging research highlights the profound connection between mitochondrial function, the gut microbiome, and chronic disease prevention. Understanding how these systems interact opens new possibilities for predicting, preventing, and addressing chronic illness at its root. In an in-depth conversation with Dr. Hemal Patel, a leading mitochondrial researcher, we explore how these critical systems work together and how personalized approaches to health can lead to lasting well-being. The central role of mitochondria in chronic disease. Mitochondria are responsible for generating adenosine triphosphate, ATP, the energy currency that fuels virtually every cellular process. Beyond energy production, mitochondria regulate oxidative stress, modulate immune responses, and influence inflammation, factors that play pivotal roles in chronic conditions such as diabetes, cardiovascular disease, neurodegeneration, and cancer. When mitochondrial function is impaired, cells lose their ability to maintain optimal energy production and protect against oxidative damage. This dysfunction triggers a cascade of metabolic imbalances that can contribute to the development of chronic diseases. Recent studies have demonstrated that mitochondrial dysfunction is not merely a consequence of disease, but often a driving factor behind it. Mitochondria and the cell membrane, the caveoli connection. One of the most fascinating insights from Dr. Patel's research is the intimate relationship between mitochondria and the cell membrane, specifically through specialized structures called caveolae. Caveolae are small invaginations in the cell membrane that act as communication hubs, regulating key processes like oxygen delivery, lipid metabolism, and cellular signaling. Caveolae help mitochondria sense changes in the environment and adjust metabolic processes accordingly. Dysfunction in caveolae can disrupt this signaling, leading to impaired mitochondrial performance and contributing to chronic disease progression. By maintaining the integrity of caveolae, cells can optimize mitochondrial function, improve energy metabolism, and enhance overall cellular health. The gut microbiome-mitochondria connection, a two-way dialogue. A groundbreaking discovery in recent years is the two-way communication between the gut microbiome and mitochondria. The gut microbiome, a complex ecosystem of trillions of bacteria, produces metabolites that directly influence mitochondrial function. Short-chain fatty acids, SCFAs, such as butyrate, acetate, and propionate, are generated by gut bacteria during fiber fermentation. These metabolites provide an energy source for mitochondria, regulate inflammation, and modulate immune responses. Conversely, mitochondria influence gut health by regulating the immune system and impacting the balance of microbial populations. Studies have shown that mitochondrial dysfunction can disrupt gut barrier integrity, increasing intestinal permeability and contributing to systemic inflammation, a condition often referred to as leaky gut. How mitochondrial health impacts the gut. Impaired mitochondrial function can weaken gut lining integrity, allowing harmful bacteria and toxins to enter the bloodstream. Mitochondrial dysfunction can alter immune responses, making the gut environment more susceptible to dysbiosis, microbial imbalance. A decline in mitochondrial energy production may impair the gut's ability to absorb essential nutrients, further exacerbating chronic disease risk. How gut microbiome health influences. Mitochondria. SCFAs produced by gut bacteria fuel mitochondrial activity and enhance cellular metabolism. Gut-derived metabolites modulate mitochondrial biogenesis, promoting the formation of new, healthy mitochondria. Healthy microbial populations produce antioxidants and anti-inflammatory compounds that protect mitochondria from oxidative damage. Mitochondria, gut health, and personalized medicine. The intricate link between mitochondrial function and the gut microbiome highlights the potential for personalized medicine to revolutionize chronic disease prevention. By identifying individual variations in mitochondrial efficiency and microbial composition, healthcare practitioners can develop targeted interventions that restore balance and optimize health. Strategies for supporting mitochondrial and gut health. Nutritional support. A diet rich in fiber, antioxidants, and healthy fats nourishes the gut microbiome and fuels mitochondrial function. Fermented foods, prebiotics, and probiotics can further enhance gut microbial diversity and support mitochondrial health. Exercise and mitochondrial biogenesis. Regular physical activity promotes mitochondrial biogenesis, the formation of new mitochondria, enhancing cellular energy production and improving resilience to stress. Intermittent fasting and cellular repair, time-restricted eating and intermittent fasting activate autophagy, a cellular process that removes damaged mitochondria and promotes the regeneration of healthier organelles. Targeted supplementation, nutrients such as coenzyme Q10, CoQ10, magnesium, and alpha-lipoic acid support mitochondrial function, while prebiotic and probiotic supplements maintain gut microbiome balance. Stress management and sleep hygiene. Chronic stress and poor sleep impair mitochondrial function and alter gut microbial diversity. Incorporating mindfulness practices and prioritizing restorative sleep can mitigate these effects. Future directions. The promise of mitochondria gut interventions. As research into the interplay between mitochondria and the gut microbiome deepens, personalized approaches to chronic disease management will become increasingly precise. Novel therapies targeting mitochondrial health and microbial diversity hold promise for preventing and treating conditions such as metabolic syndrome, neurodegenerative diseases, and autoimmune disorders. Dr. Patel highlights the potential for using advanced diagnostic tools to assess mitochondrial health and microbiome composition, paving the way for individualized treatment protocols that address the root causes of chronic disease. By embracing this integrative approach, we move closer to unlocking vibrant, lasting wellness. Conclusion. Mitochondria and the gut microbiome are intricately connected, forming a dynamic partnership that influences metabolism, immune function, and inflammation. Understanding and optimizing this relationship can lead to more effective prevention and treatment of chronic diseases. Through personalized interventions that target mitochondrial health and microbiome diversity, individuals can take control of their well-being and cultivate long-lasting health.